over and over and over again to build my select list. And then I'm going to construct and parse my query. So I'm going to add a where clause. If somebody's provided a where clause string, if it's not null, then I'm going to put this information onto in my where clause variable. And note, this could lead to problems regarding SQL injection. This is covered, the SQL injection topic is covered in best practices. Then I construct my query. Well, it doesn't get more generic than this, does it? It's a select statement. Here's my list of elements I'm selecting from my table for a given where clause. Wow, very, very generic. But okay, I constructed this from my list of columns, my where clause that's provided by my user. There's my query. So the next step is to parse it. So I pass in my cursor, I specify my query, and native behavior. Native, or this third argument, is something that was an issue back when Oracle first released Oracle 7. So you could specify you wanted Oracle 6 behavior. But there's really no reason to do any of that now. Just specify dbms SQL.native. So I parse my query. Great, assuming there was no error. And now I can move on to defining my columns and executing. So basically, before executing the query, I need to tell dbms SQL the data type of each of the columns being selected. So for every one of my columns, if it's a string type, I'm going to define, here's my defined column program. I pass in the cursor, the nth column, the type of data, and the length of the data. At least for strings, I have to provide the length of the data. If it's a number, I specify cursor, the index, and a number value. Date, I specify a date value. This is a very interesting kind of overloading. Basically, it's using the type of data to determine which of the defined program overloadings to call, defined column overloadings to call, and then setting the appropriate information internally. I could have done something like defined column. The nth column is a string, literally passed in the name varchar2, but that's not how this works. You pass in a piece of data of the matching data type, and then Oracle uses that information to say, okay, that's a string, the second one's a number, the 15th is a date, and so on. Clearly, my implementation only works for strings, numbers, and dates. So if you want to extend it to support other things, you'll have to do that yourself. Okay, so I define each one of my columns. Now I'm ready to execute. So I execute the statement. Now, if this was a DML statement like update, insert, delete, then I can immediately get the feedback, which is the number of rows that were modified, and I can look to see if my statement succeeded. When you're executing a query, the feedback is basically irrelevant. If it doesn't raise an error, the feedback can be ignored. And the next step, though, is that I need to retrieve the data from my table. So, I'm going to build and display the output. Again, a lot of this has to do with the formatting of my code. But let's go down to the main body of code, which is the loop. So again, I need to loop and fetch individual rows. So I call the fetch rows program to fetch a row of data, the next row of data. You can also fetch multiple rows and fetch into collections as an option with dbms SQL. So I call fetch rows. I pass in my cursor, and it's keeping track of the location in the cursor. So I get my feedback, and the feedback basically says how many rows did I fetch. In this case, it'll be 1 or 0. So I exit when my feedback is 0. Okay, I got a row of data. Now, once again, I have to iterate through all my columns because I want to fetch the individual values. So while I've got another column, if it's a string, call column value, cursor, the index, and then retrieve it into a string variable. If it's a number, I'm going to retrieve it into a number variable. Date, retrieve it into a date variable. And then I'm going to construct the string of code that's going to be used to display it. And that's it. So I fetch until I'm done. Well, I've got a row that I still need to work with. I have to call column value to grab the individual value. So this is my into clause in my dynamic SQL statement. And as you can see, it's very dynamic. I don't hard code in advance how many elements I've got. Finally, for cleanup, the main thing is make sure you close your cursors. When I open a cursor in my local body of code with dbms SQL open cursor, Oracle will not close that cursor at the end of my program. unless I explicitly tell it to do so. So if it's still open, close that cursor. And that's it. I would say that's all, but that's a lot. So there are many different operations you have to perform. This is a relatively simple example of dynamic SQL method 4 and barely scratches the surface of what's possible to do with DBMS SQL, but it certainly should give you a good idea of the different steps that you have to follow. And again, the main thing is to understand this basic flow, and of course, check out the DBMS SQL documentation. Let's take a look at the other aspect of method 4, dynamic binding. So at the time I write my program, I don't even know how many placeholders I've got in my string. Since I don't know how many placeholders, which is a colon followed by a name, since I don't know how many placeholders I've got, I don't know how many expressions that I will need to bind into those placeholders. Therefore, I cannot use the execute immediate using clause because it's static. And instead, once again, I'll use DBMS SQL. It's much better suited, and in particular what I'll do is take advantage of the bind variable subprogram. Let's take a look. Here's my method for bind variables program. I pass in the SQL statement, whatever it might be. I pass in a list of placeholders. I pass in the corresponding list of values, and these are using a predefined array structure in DBMS SQL, basically a list of strings. I open my cursor. I parse my statement. So in this case, I'm assuming that there is no different columns that I need to define. What I do need to do, though, is bind my variables. So for every one of my values in my list, I'm going to call DBMS SQL bind variable, pass it the cursor, pass it the name of the placeholder, pass it the value. And again, bind variable is overloaded for the different types of data that DBMS SQL supports. Let's actually pull up the definition. Pull up the definition of DBMS SQL. So here's the DBMS SQL package. Again, lots and lots of stuff. Wow. Here's bind variable. So notice there are different overloadings of bind variable for the different types of data: value number, value date, blob, b-file, etc., etc. So that's partly why DBMS SQL is so big. It has to have all these overloadings for all the different data types. And as you can see here, you can also bind an entire array of numbers, an array of strings, an array of dates. So you don't have to bind individual values if you want to use bulk processing with DBMS SQL. So in this case, I'm using a very simple scenario. I'm passing in a set of placeholders of strings. So for every one of my values, I call bind variable. So there's my dynamic using clause. I execute my statement, and then I'll take a look at how many rows were modified by executing that statement. And then, some of you may have already realized, I left off a program, and that is, I need to close my cursor. So close cursor. Okay. In my example script, I've got a list of placeholders, a list of values. I find out how many employees are, or the sum of salary in the employees table for department ID is 50, and I'll display that value. Then I'm going to populate my placeholders with two names, salary and department ID, and values. 10,000 for salary, 50 for department ID. And then I'm going to execute my dynamic SQL clause statement. My apologies. Now this is not actually dynamic SQL, but I could have a variety of table names, column names, whatever the case might be. Assume that it's dynamic. Because what I want to show you is that even if I don't know how many values I have to bind in at the time I compile my code, I can take advantage of arrays of values, placeholders and values, to do all that work for me dynamically. And then afterwards, I'll see how many people are now, or the sum of salary now for department ID 50. And when I run this code, whoops, method for bind variables is invalid. What did I do? Let's see. Let's compile the program. And my message is, wrong number of types of arguments. Yes, that's what happens when you write code on the fly. I want to close my cursor, but what cursor am I closing? I need to tell it. Silly me. So let's put that there. Let's see if it compiles now. That's better. Okay, so when you close your cursor, specify the cursor you're closing or Oracle will let you know. Run my code. No errors. Display the output. Before I did my update, the total salary was $168,000. After I did my update, total salary $450,000. Therefore, you can safely assume that there are 45 employees in Department 50. 45 times 10,000, 450,000. So it did the job, and it did it because I was able to dynamically, at runtime, sort through the number of placeholders I had and do my binding. Now, if I don't do all of them, for example, let's do account -1 here, and I try to run this code again, I get not all variables bound. So when you're doing dynamic SQL, if you get this message, if you're using execute immediate, you need to go back to your SQL statement and compare the number of placeholders with the number of elements in the using clause. If you're using method 4 in DBMS SQL, then it's a little bit more difficult to track down the problem, but the bottom line is that all the elements, all your placeholders in your string are not being matched up by values with a bind variable call. So what you want to do is look at the string that's being executed dynamically, and we'll talk about how best to do that under best practices, and then go back through your code that is generating the number of different bind variables and make sure that they match. So there's an example of method 4 dynamic SQL when you don't know the number of variables that you're binding in advance. Conclusions. Method 4 dynamic SQL is relatively uncommon, but it's also very, very complicated. Most of the dynamic SQL operations you're going to face are situations with a little bit more certainty. I know how many elements I'm selecting. I know how many bind variables I've got. You don't have to worry about this level of complexity. You can stick with execute immediate. But because you know so little about the SQL statement you're executing in this case, you have to fall back on DBMS SQL. Then you get all the control you need, but wow, it comes at such a price. It requires a lot of code, lots of careful programming, lots of good debugging, and lots of good error handling. But the result is a very flexible program that can handle just about any requirement you've got. So I hope you found this useful, and you definitely will want to check out the other, talk about next steps. I hope you found this useful, and certainly in this case you want to download the demo zip, take a look at each of these files, try out my end tab procedure, step through the code, make sure you understand how it's getting done, what it needs to do, check out the dynamic bind variable program as well, and then you'll be in good shape to tackle more complex real-world scenarios. And certainly, after you've dealt with method 4 dynamic SQL, everything else is going to seem pretty darn easy. So check out the other advanced topics, which mostly cover other features of DBMS SQL that might be of interest to you, and Oracle 11g new features, which adds a number of really interesting new features to the dynamic SQL scenario, especially interoperability between native dynamic SQL and DBMS SQL. I hope this was helpful to you. Happy coding.